and welcome to Tyre and Rubber Recycling Podcast 74 with me, Ewan Scott. In this edition, we will be talking with John Loudermilk, the CEO of Aditya Birla Carbon, for an update on the latest developments in Continua and the finalisation of the RCB improvement facility in India. Before we get there though, don't forget to subscribe to this channel to stay updated with Tyre and Rubber Recycling podcasts, or subscribe to Tyre and Rubber Recycling magazine for regular news updates. You can also follow us on Facebook, LinkedIn and WhatsApp. The links are in the comments below. So, without further ado, let's hear what John Loudermilk has to say about Birla. Can we open up with your view of the place of tyre-derived recovered carbon black in the future of the sector? How important is the development of consistent standards in creating the market conditions that would allow the growth and acceptance of recovered carbon black?
I think carbon for end-of-life tires, recovered carbon black, or in our case, we describe as sustainable carbonaceous material. Over the long term, we see it as having a critical part in the overall supply chain for end uses that carbon black supplies today, not only tire, but others, and would expect that in the long term, maybe up to 10% of the applications will use sustainable carbonaceous material rather than carbon black based on its unique performance characteristics or its potential use with carbon black in these applications. There are certain properties that it just doesn't have today and carbon black is better suited for, but there are others where it has advantages or can be used in combination. And so that level of 10%, when you look at a global industry of 16 million metric tons of carbon black consumed today, is something that we see as certainly attainable. And over the long term, as you're able to manipulate this material or modify the surface chemistry, could be even greater. You mentioned consistency and testing standards, things of that nature. In your 15 years, I'm sure you've seen this pyrolysis process has been around for a very long time, and typically applied at small scale to demonstrate the technology, but not at large scale to provide security of supply and consistency. And finding a way to economically justify that leap has been a real challenge. And giving confidence to the customer base that the suppliers can provide that consistency and security of supply has been a real challenge. So that really is how we decided to step into the business. We looked at a wide range of alternatives, whether it was developing technology, acquiring technology, building plants, and really saw that our place was our understanding of the supply chain, our understanding of carbon black and how the product works in a variety of applications, and providing that credibility to the customers. And that's why we've chosen to partner with manufacturers who've developed interesting technology that can take advantage of scale we can bring. But the consistency piece is the part that we've really focused on with customers. So understanding what their needs are in each application, being able to define those requirements and demonstrate we can prove the quality and then provide it consistently, whether it's from the single factory that's being scaled today in the Netherlands with CertTech to make material in Europe, or our partner Finster that is a joint venture partner in India to provide Continua in India. Continua 8030 to provide consistency to those customers for those applications. So we really see the consistency piece and the confidence of the customers to accept that quality level and consistency as being the key to scale. And we think that's what we're really bringing to the industry because of our credibility as a carbon black supplier and understanding of the supply chain, value chain, and customer base.
Okay, is there a maximum percentage recovered carbon black that you envisage being able to incorporate in sustainable carbonaceous materials?
So yeah, for us, when we say sustainable carbonaceous material, what we mean is the recovered carbon black from end-of-life tires. So that product is 100%. That said, we expect to offer 100% material from end-of-life tires, as well as a variety of blends with carbon black. In terms of the applications, each one will have a different requirement in terms of how much it eats. We've certainly found some that can use 100% sustainable carbonaceous material from end-of-life tires. The tires themselves, carbon black provides some really important characteristics around wear properties in the matrix. It's not going to be replaced by material from end-of-life tires. It will be augmented. I think in some subparts, whether it's in carcass or sub-tread, you could get very high percentages of Continua or sustainable carbonaceous material, maybe 50, 60, 70, up to 100% in some small sub-components. But for the tire as a whole, I think somewhere around the 5 to 10% level is achievable over the long term. But it does require formulation changes in the polymer matrix.
Right, yeah. And what are the limiting factors in utilizing recovered carbon black? I ask because I have heard many people from the sector over the years talking about high percentages and the wonderful things that their materials can do. And in 15 years, it's only now I'm starting to see movement. So what are the limiting factors?
Yeah. So I think your first point is a good one. Can whatever the product is be provided at a level of consistency that gives the customer confidence to use it? Because what they've seen is each sample I get or each load I get looks different, and that created challenges. Any individual component is okay, or these different specifications may be okay, but they have to be very consistent. So that's one thing. The product itself has a lower level of surface reactivity and surface chemistry, so it behaves differently, and that limits its ability to reinforce the way carbon black does. Part of that is just because you're getting material from end-of-life tires, which includes non-carbon black material, so you're getting silica and other components that are a part of it, and they don't react the same or have the ability to react. The surface chemistry of the carbon itself is different. So there are potentials to modify and kind of reactivate the surface. That's not the product we're providing today, but a lot of research is going into that, and I think that will enable more applications. But in my mind, if you can provide a product with a level of specification very consistently, the potential to use this material today is kind of in that 5 to 10% of the carbon black weight going into tires. So carbon black is typically 25%, roughly the weight of the tire, right? So 5 to 10% of that could be Continua or sustainable carbonaceous material in the tires. There will need to be additional development work to improve the reactivity of the surface that would then potentially enhance that. The challenge there is typically those process steps take additional energy. I mean, you mentioned, for instance, our Asia post-treatment project in India. That's a post-treated carbon black. So we're surface treating the carbon black. That requires a lot of energy to do the post-treatment. So the benefits of the reduction in carbon footprint could be impacted by that. So some of the future development for sustainable carbonaceous material will have to balance out between the sustainable aspects and the carbon footprint versus the performance requirements. It may be long-term, it makes more sense from a carbon footprint standpoint to use virgin carbon black than it does to further treat the sustainable carbonaceous material. But that line will constantly be moving as regulations, the value of CO2 change, and advances in technology.
Yeah, and of course, energy prices change dramatically depending on what's going on in the world. I read recently that whilst India has low labour costs and relatively low property costs, energy costs are high, and for pyrolysis, you're going to use a lot of energy, despite what some people say. My reading is that there's a high demand for energy there. Okay, so let's talk about your new product, Continua 8030.
Mm-hmm.
This is one of the points you wanted to talk about. So tell me about it.
Yeah. So the first Continua product we developed was Continua 8000, and it's tailored to customers' needs primarily in the European market. When we look to spread our capability globally, and we will be expanding this over the long term, and we looked in Asia specifically, there are certain aspects of the material that could be varied, both in terms of the feed components to make the sustainable carbonaceous material, but also their requirements and application. And so the 8030 is a variant that it is matched to those two requirements, what's available in Asia and what's required in Asia. We've developed a partnership with Finster, made an investment in the joint venture to manufacture this material. And again, scaling to a large quantity to give our customers consistency and security of supply at that product specification. So it's really not a huge difference from 8000, but tailored more to the local market needs, particularly in India today, but something we see as relatively consistent across many of our Asian customers.
Okay. And the post-treatment plant, Patalganga, I shouldn't even have tried to say it.
It's not the most complicated site I've been to pronounce, but it's one of. Patalganga is the name of the site. It's just outside of Mumbai in India.
Right. So tell me what is happening here? What is happening at that plant?
Okay. So Birla Carbon obviously makes materials that go into kind of every market sector and potential application. Tires are a large consumer for carbon black, and it's a very important business for us that we continue to invest in terms of core business. But we also provide materials that go into every other application, including plastics, coatings. And when you get into these coatings applications and certain others, the importance is the surface activity and providing deep color, things of that nature, and you have to treat the product. We've traditionally made this material only at one site, the United States, in Louisiana. And if you look at the big global players, they tend to have a very limited number of production sites. Most of the growth and demand is clearly in Asia. So we've historically exported out of the U.S. into every other market with large quantities going into Asia. What we wanted to do was create this capability locally to supply the local market, and we are transferring certain product lines so we can unload our factory in Louisiana to continue to ramp up other high-value materials for the Western market while we make material closer to our customers in Asia with a post-treated product, particularly for coatings and other liquid systems applications. So that's kind of the logic behind it. It was a capacity expansion, and it really doubled our capability to make post-treated product. We wanted to make this expansion in a place that was closer to customers and closer to growth. The other advantage it provides is it improves the sustainability of that supply chain, because instead of moving material around the world, we're providing customers closer. So we're reducing the supply chain costs and also taking advantage of the serendipitous energy cycle in a carbon black plant. As you know, when you produce carbon black, you also produce energy. You mentioned energy values are expensive in some parts of the world, India and others. We're a net seller of energy as opposed to a net consumer. So taking advantage of an existing factory where we produce carbon black and energy to also utilize that energy for this post-treatment technology and provide product closer to customers and reduce the supply chain CO2 and cost impacts is important to us. This also happens to be the site that's jointly located or adjacent to our partner and joint venture with Finster to make Continua 8030. So it gives us that opportunity to look at technology advances between all three, blending capabilities and supply chain advantages, as well as kind of the laboratory and technologist critical mass in that one location. So Patalganga winds up being an important site for us on all three fronts. Our core business to make carbon black that goes into tires and standard applications, our high value specialty business to post-treat carbon black and make very high value specialty products for things like top coat paint for automobiles, and sustainable carbonaceous material and Continua locally that can be utilized in each of these applications.
Okay, right. Now, as we're talking, I'm thinking a few years back, I visited Tyre Tech in March, and as I say, a few years back, and I spoke to carbon black people at Tyre Tech, and I asked them at that point about recovered carbon black, and their view was it was a waste of time. It was never going to happen. But now when I go to Tyre Tech, you're all there, Birla, Orion, Cabot, and you've all got sustainable blacks using recovered carbon black materials. What has been the driver that has brought about that change, that you now all push sustainable blacks?
Yeah, so I can't answer on behalf of our competitors, but I think for Birla Carbon, we had an open mind early on that material from end-of-life tires and sustainable carbonaceous material will be an important part of the answer. You mentioned the term sustainable carbon blacks. We use that to describe carbon black that's produced from renewable feedstocks. So whether that's tire pyrolysis oil, pine tow, and other things like that, right? Where we can make carbon black using alternative feedstock that tends to be both higher cost and lower efficiency. So it's a much higher cost product, but it's consistent with standard carbon black. Whereas sustainable carbonaceous material is a different material from end-of-life tires. I think what we heard early on across the industry was there was a confidence in sustainable carbon blacks being accepted because they're the same, and that's true. But economically, they're not as attractive for a lot of applications and hard to get in. And finding this balance between economics and sustainability is the key. And we think it's a continuum. So there are applications where this will make perfect sense, much like, recovered plastics turning back into raw material chemicals and converting back to plastics. It's very expensive, but it makes sense for certain applications. But you're going to have to find something more economical, and sustainable carbonaceous material for end-of-life tires is part of that. The product itself is closer in cost to a standard carbon black. It's not necessarily exactly the same. There's a lot of capital to build these plants, and you mentioned they're very energy intensive. But because of the circularity and mobility of the feedstock, it can be more cost effective. But you have to change the formulation. So we have to partner with customers to find the right formulation to use these and the right applications. I think early on in this industry, there was a view that it's not going to work like carbon black. You have to get over that and say, that's correct, but it has application, and you have to find those uses to make money and be profitable for our customers and value chain. So I think as we've all gotten closer, Birla Carbon was the first to make a commitment to net zero by 2050. Our competitors that you mentioned have followed since then. There's a recognition now that this has to be part of the solution. You're never going to completely decarbonize carbon black production just by using renewable feedstocks. You're going to have a suite of solutions to do that. New process technology and how you make carbon black, new feedstocks to make carbon black, and circular materials from end-of-life tires. I think it's really just an evolution of understanding that there is no one answer. And ultimately, while this won't make a material exactly the same as carbon black, it makes a material that has advantages and applications. We have to find those and use it. Our sister company, Novellus, is the world's largest aluminum recycler and rolled aluminum company in the world. And, aluminum is that miraculous material that's kind of endlessly recyclable. We take a lot of inspiration from that history in their industry. And so early on made the decision that finding a way to create circularity for end-of-life tires would be important for our customers, and it provided an attractive feedstock for interesting materials. Not carbon black, but sustainable carbonaceous material can be applied in some of these same end uses.
Okay. It's been an interesting discussion, and it's an interesting market development we're seeing, I think. I go back to early days in the industry, and I would hear maybe 30 or 40 people a year with a pyrolysis project. And I viewed it very much as a bit of the Wild West. There were some true pioneers there, but there were also some cowboys and some snake oil salesmen. And I think we're getting past that now. There's still a few around, but I think we're getting past that to the point where the industry is starting to mature. And at the RCB conference last year, there were over 300 odd people there from around the world talking seriously about a recovered carbon black sector. So I've seen a lot of changes, and it's good to be able to talk to somebody at the top of the tree, if you like, in the sector. So thank you very much for your time.
Great. I appreciate it. We're clearly real believers, but I think one of the real challenges to go from those early nascent stages to true scale is you've got to have, an economically viable and investable solution. And scale is an important part of that. Confidence in the customer base to take it, kind of getting over this do loop of until you commit to it, I can't invest. Until you invest, I won't commit to it. And that was kind of the middle ground that Birla Carbon was willing to step into and make guarantees to both sides. And I think you will see professionalization of this industry, and it will look a lot more like the carbon black industry in 5 years than it looks like that history you're describing for historical recovered carbon black going backwards. But we're not there yet. We're a long way from 5 to 10% of the industry being supplied by this material. So long road ahead, but we're really very confident in the potential.
I suspect you guys are on the right road now.
Well,
okay.
We're at least near the right road. We're constantly honing in on it. So I appreciate your time today, Ewan. This is really interesting. And obviously, if you have any other questions or concerns, don't hesitate to reach out. This is certainly an area we're passionate about, and happy to learn more from what you learned as well.
I think the main takeaway from this discussion is the change in the approach of the carbon black sector to sustainable materials and the use of recovered carbon black. The tire pyrolysis sector has moved from being a frowned upon outlier to become an integral element of the carbon black sector, and this is only the beginning. We can expect to see ever-increasing volumes of RCB and TPO being used in the future as ever larger processing facilities come online. I'd like to thank John Loudermilk once again for his time with us in this podcast. In the meantime, thanks for watching, and we'll be back shortly with podcast 75. Take care and mind how you go.